in general. And I think the book have a name for this equation. Let me look for it. This is called scalar equation of the plane. Okay. So with this equation of the plane, the normal vector V is A, B, C. Okay? And D here is equal to negative of A's x naught plus B y naught plus C z naught, where A, B, C is the coordinates of the normal vector, and x naught, y naught, z naught is a fixed point on the plane. Okay. And usually I claim that this is how we usually write, give it to you, because it's making it harder for you to learn, to calculate. When you do your math, this is what you should think of. Okay. You dot between the normal vector and any vector on the plane is going to be equal to 0. You figure it out. And instead of writing this way, this is how the book writes. So what we're going to simplify this first. It's going to be easier for you. Let me start from here and show you another way. And you still have the same formula anyway. I think they will give you this too. R minus R naught is going to be what? X minus X naught, comma Y minus Y naught, comma Z minus Z naught, and then everything gonna dot A, B, C. Okay? So what? You dot the two vectors, it's X minus X naught times A plus Y minus Y naught times B plus Z minus Z naught times C equal to 0. And you also have the equation of a plane. Related to the two-dimensional space that you guys learned before about the line, this is like the slope-intercept equation. This is, I think, this is kind of like the general equation. This is like the point-slope equation, kind of similar. Okay. I think I should give you an example before I move on. Let me give you an example. Example. Say, find the equation of the plane that goes through the point, say 2, 0, 1. This is the point that I give you. And I give you the normal vector. This is the point P. Normal vector is 1, 2, -1. Okay? So how do you find the equation of the plane that have a point 2, 0, 1, and the normal vector is 1, 2, -1? Okay? Apply the formula right here. Look, man. So what the equation of the plane is going to be? X minus X naught times A plus Y minus Y naught times B plus Z minus Z naught times C equal to 0. So X is the variable, X naught is 2, and A is 1. This is X naught, this is Y naught, this is Z naught, okay? This is A and B and C. X minus X naught times 1 plus Y minus 0 times 2 plus Z minus 1 times -1 equal to 0. Then you multiply them out, you simplify by the like terms, you have the equation. This is what? X minus 2 plus 2Y minus Z plus 1 equal to 0. See? 1 times X is X minus 2, 2Y, 0, and what? -Z, and -1 times -1 is plus 1. 0. Okay? Combine the like terms and numbers, what? X plus 2Y minus Z, -2 here plus 1 there is -1 equal to 0. So here what? A is 1, B is 2, Z is -1, and D is -1. The normal vector is 1, 2, -1. 1, 2, -1 right here. Okay? And -1 right here is the D value we're talking about. That's it. And the last formula for this section is the distance formula. You have a point and you have a plane. How do you find the distance between the point to the plane? Here's the idea. Say we have a plane. Okay? And you have a point off the plane. That's point P. Okay? You project it down to the plane. It's called P naught. It's called the distance D right here. Distance from a point to a plane. What you know is the equation of the plane. And you know the point P right here. How do you find the distance? Okay, and here comes the formula. Let me just copy the formula down for you first. So what you have is a point P right here called x naught, y naught, and z naught. I need some variables in here. And the plane is the plane. Equation for the plane is what? Ax plus by plus cz plus d equal to 0. We just learned that a minute ago, right? So looking at this, you know that the normal vectors are obviously going to be A, B, and C. Okay? So the distance d between the point P to the plane is calculated. This way it's going to be a fraction. The bottom will be square root of a squared plus b squared plus c squared. Yeah. And the top going to be absolute value because we want to make sure that everything is positive. That's what? Ax naught plus by naught plus c z naught and then plus d. Make sure that I got it right. Yeah. So what? Log x, y, z by the point and then divided by the magnitude of n. There are a couple of ways. I think I'll say a couple of ways to prove that the distance equal to this. Some method is you don't know this point P naught right here. All you know is the point P, right? And this is the distance. You just randomly choose a P naught somewhere in here. Okay? And you draw a line, and then you find the projection. This is one of the way, or you find a normal vector. Right? You have ABC right here. You find a normal vector, which is the directional vector. You go through a point P. You can draw the normal line right here. Okay, the equation of the line and the equation of the line going to intersect. The plane at the point. You have 2 points. You can find the distance between the 2 points. That'd be easier. I think the book used projection, but you can find the. See, this is my idea. You have a point right here, right? You know the normal vector, right? So have a point, normal vector of the plane is the same thing as the directional vector for the line right here. You have point and directional vector, you can find the equation of that line. And you solve the equation of that line intersecting the plane, you have the point P right here. Okay? You have the point P, called P naught, I think. And then after having P naught and P, you find a distance. You have a formula. And anyway, this is the formula. Okay? And this is the end of 12.5, talking about equation of the line and equation of a plane on the 3-dimensional space. Now let's move on to the last section for our clip today, section 12.6. We'll be talking about 3-dimensional surfaces, and I claim that the book does a much better job than I'm going to draw it on the board, so I urge you to read the books, only a couple pages, from page A34 all the way to page 39. A39, only 5 pages, okay? So pretty much to give you the equation. So let me try my best to draw the 3D object on the board. First of all, the ellipsoid. So 2D, you got an ellipse, right? Now 3D, because the ellipsoid. Right? And again, excuse my drawing. Like a football. The equation of this one is going to be x squared over a squared plus y squared over b squared plus z squared over c squared equal to 1, where x, y, z are variable and a, b, c is the center. The center is at a, b, c. Oh, no. A, B, C just numbers, okay, not the center, just like the ellipse in 2D. Center at 0. Center is at 0, the origin. X, Y, Z, right? From here to here is C. From here to here is B. And from here to here is A. And recall what you learned in pre-calculus, you got an ellipse in 2D, right? X squared over a squared plus y squared over b squared equal to 1. So a goes with x, this is a. B goes with y, this is b. Okay, now 3Ds look like that. The C goes with z. So x, y, and z, and center is origin. And to make it more general, if you have same ellipsoid, center somewhere else, a k out, and what x minus a squared, y minus k squared, and z minus l squared. Now we have the same ellipse to shift it to the new center of 8kl. H, K, and L. Okay. That's the first one. Okay. One more time, excuse my drawing because I'm not very skillful in drawing. Okay, but I urge you to read the book. They show you color graphs of those things much better than the way I draw. Second one, elliptic paraboloid. So you start with a parabola. The first one with ellipsoid, right? Ellipsoid. Second one gonna be elliptic paraboloid. And this is, you start with a parabola. Okay, now 3D parabola. You're kind of rotating that parabola around the axis of symmetry. So you have something like this. Okay. Okay, looks like a cup. And the equation for this one is this: z over c equal to x squared over a squared plus y squared over b squared. Center right here. X-axis, y-axis, and then z-axis. Think of it. What if y equal to 0? Then you got what? Z equal to something x squared, right? So this is a parabola with the x and z plane. Jump it up this way. And if x equal to 0, then what? Z equal to y squared. Z and what? This is the plane right here. Either you jump this way or you jump this way. Okay? And you have parabola surface. Okay? So another one, the cone. Now this is easy to draw. This is mathematical cone. Okay. And the equation for the cone is this: z squared over c squared equal to x squared over a squared plus y squared over b squared. Okay. And center at the origin right here. This is the y-axis, z-axis, and this is the x-axis. Okay. Another one, hyperbolic paraboloid. It's like a horseback, so I don't know how to draw it. Let's see how to draw this one. I have a parabola. I have a parabola. I don't know. The book draws much better than me. So it's like a horseback. Let me see. See why I asked you to take a look at the pictures in the book, because they have computers who draw it much better than I do. So let's see. Okay, try it this way. Okay. Hopefully that makes sense to you. That help? So now let me just write out the equation. That's when I'll stop right here because I don't want to embarrass myself with drawing. This is what z over c equal to x squared over a squared minus y squared over b squared. And the pictures, I think it's on page A37 in the book. And again, excuse me for my drawing. And let me see. And actually, this is the end of our video clip today. Thank you for watching, guys. One more time, if you have any question, please email me, or we can set up a time so we can go face to face if you like to. Just let me know ahead of time so I can arrange the schedule. Thank you for watching and have a good day.